4. For each of the isotopes in exercise 21.1, determine the number of protons, neutrons, and electrons in a neutral atom of the isotope. Okay, and then we have this example here, which is one of the examples in exercise 21.1. So we have 194 on the top, 77, and IR. Okay, so from this, we just have to find out how many protons, neutrons, and electrons there are. So let's just write that down. So, okay, we're going to find out protons. I don't like how that O looks. Protons, neutrons, electrons. Okay, sorry. All right. So, there we go. Now, the first thing that I noticed is that in the instructions, they did say that this was a neutral atom, which means that the overall charge of the atom has to be neutral. That means that it has no charge, right? Neutral, no charge. And there's only one number in this world that is not positive and not negative. It's neutral. It has no charge, and that is 0. So that means that the overall charge of this iridium is a 0 charge. But there are some subatomic particles that have charges, so they have to cancel out. So all of the positive charges that the subatomic particles have, right, they have to be combated with the negative subatomic particles. So if I have like a +5, I would have to introduce 5 negatives to cancel them out so that the overall charge is neutral, which is 0. So whatever positive charge I have to equal that out to the negative charge. But the question is, which subatomic particles are positive and which ones are negative? Well, the positive ones, P goes with positive, right? So we have protons. The positive subatomic particles are protons. And the protons have to equal the negative subatomic particles, which are the electrons. So positive protons, all these P words, I'm getting twisted up here. So positive protons, negative electrons, we'll color that in blue, and they have to be equal to each other. So that means that if I know what the proton number is or what the electron number is, I know the vice versa, right? Because they are going to be the same. But let's just figure out how we're going to find 1, right? So now that comes into these two numbers. I got 194 on the top and 77 on the bottom. Now, the higher number, wherever they place it, right? Generally, they should place the number on the top, but the higher number is always the atomic mass. So the mass number or the atomic mass is on the top or the higher number. The lower number, which in this case is 77, is the atomic number. Now, one of these is a unique value to its element, and that is the atomic number. 77 will always be iridium's atomic number. 77 will never be anybody else's atomic number. So like atomic number of 1 is always hydrogen. Atomic number of 2 is always helium. So if you change an atomic number, you will completely change the element. And it turns out that the atomic number is the number of protons. So each individual element has its own special number of protons. So 77, right? That's the number of protons for iridium. So I'm going to go over here, 77, and go over here to protons and say, hey, that's how many protons I have, 77. But since we just said that it was a neutral atom, we know that we have 77 electrons. So we have 77 positives being combated by 77 negatives, and together these will cancel out in charge, and it will be neutral. Keep in mind that the neutrons, neutral, no charge, NN, they don't have any charges. But now we just got to find out what or how many neutrons we have. Well, this has to deal with something with the atomic mass, right? And you're absolutely correct. Now, the atomic mass is the bulk mass of the element, and the bulk mass is found in the nucleus. So we ask ourselves, what subatomic particles are in the nucleus? And in the nucleus, there are protons So we got the protons in there, and we have the neutrons. Keep in mind that the electrons are in the outer ring of the element in their orbitals. But as far as the mass goes, it's just the protons and the neutrons. So, oh boy. So the question is, how are we going to manipulate these two numbers to get to just the neutrons? If the mass is the protons plus the neutrons, and the atomic number is the protons, what would we have to do with these numbers to get just the neutrons? Yeah, you're absolutely correct. We would subtract them, right? We have to subtract the two of them to get the number of neutrons. If we subtract these two values, the protons go bye-bye, and you're now left with neutrons. So in essence, you would do 194 minus 77, and that will get you the number of neutrons. You could also, plug this into the calculator if you wanted to. Do old school math, which I might do. But yeah, any which way, just to get the number of neutrons. So 194 minus 77, let's see. So we have a 4, this would be 14. This would be an 8. So you got 117. So we'll just say 117. And I could also just double check by adding these two together just to make sure I get 194. 7 and 7 is 14. That's 9 and 1, so we're good to go. So 117. And we're done. So we got 77 protons and electrons because it's neutral. And you have 117 neutrons. And that's it. What'd you think? I hope this helped. Let me know in the comments. Subscribe to the channel if you want to, if you haven't already. And if you want to help the channel out even more, you can become a member. There's 4 different tiers with tons of perks in them. So one of them might fit your fancy. So check it out. Not obligated, not mandatory, obviously. But any bit that helps us will help you out in return because we can then post out more videos for you guys. And we got cool stuff coming your way for the new school year. So I'm excited about that. But anyway, I hope you're having a great day, and I'll talk to you soon. Okay, bye-bye.